that is this, children. In case you forgot, we did this way, way long time ago. When you're given a systems of equations, let's say you get y is 1/5 x plus 2 and y equals negative 4x minus 1. Here is the deal, okay? When you have a system of equations, these are the three possibilities you get, okay? And they tell you here. One possibility is that when you graph those lines, they will actually cross at one single point. When that happens, it is called consistent and independent. Don't ask me why, I don't care, but just know that that's what it is. Consistent and dependent. That's why I gave you the notes, so you can look it up if the book asks you or somebody asks you. Okay? Your second choice is, if you graph two lines, they happen to be the exact same line, that would be this. When you graph them, they end up being right on top of each other. That is this. There's an infinite amount of solutions, because any point on either one of those, which are the same line, would be an answer. That is called consistent and dependent. And your third choice is the lines will never cross. They cross once, they're the same line, or they never cross, they're parallel. You look and their slopes are the same, but they have different y-intercepts. That is this one, and it's called inconsistent, and there are no solutions. We actually talked about it before, we didn't really say a whole lot about it, but this is actually going back a couple minutes. But now you have that in your little repertoire and in your notes, so you can look at it. Take a look at page 439. I think I got this here. Hold on a second. Oh no, don't hold on. Open up to 439. Less than 60 seconds.
I've seen it.
Yes. Take a look. Take a look. Don't worry, I'm right here. Take a look, take a look, take a look, take a look. And this is how easy this is, people. This is the practice from your book here. What's it say to do in the practice? It says solve. If you're looking at this, please look up here and note this. Okay, when you're given two lines to graph, before you even graph them, what do you notice about these two lines and their slope? They're the same. So if they have the same slope, one of two things has to be true. Either they're the same line or they're parallel lines. And this, since it has different y-intercepts, means it's going to be parallel line. So if you're solving this, boom, boom, what is the answer to this? You don't even have to graph it, because two parallel lines, what does it say on our little notes for today? Parallel lines have how many solutions? Right, there's no solution to this, because they're parallel lines that won't ever cross. Okay? Now this one here, you may actually have to graph, because maybe you can't see what's true on this. If you graph this, it's in standard form, so you're going to graph with x and y intercepts, correct? The top one, what do you get? If x plus y equals 10, what are your intercepts? X intercept is 10, because you put 0 in for y. Y-intercept is 10. So the line you get is this line. For the second line, x-intercept is 10. Y-intercept is 10. So you end up with the same line, which, what's the answer when you have the same line? Yeah, there's an infinite amount of solutions. Infinite amount of solutions. So then letter C, take a look at letter C with me, please. Where's my eraser? Looking at letter C, it says to list them as either independent, consistent, or dependent or inconsistent, which means just what we wrote on that stuff there. What do you think about these two lines here? Are those the same? They're the same equations, really, because you can change all the negatives. So what are you going to label this as? You look on your notes. The same line is what? Consistent and dependent. The next one. You don't know what the slopes are of these, but you can sure figure it out. What would you have to do to figure this out? You have to solve for y. So on this top one, you're just going to move the x over by doing what to it? Add 2x. So this equation becomes y equals positive 2x plus 3. What's the slope of this line? 2. What's the slope of this line? Negative 1. If they have different slopes, what does that mean has to happen? They have to cross somewhere. There's no way that you can have different slopes and those lines won't cross somewhere in the scope of everything. So what is the answer to this? Look in your little sheet there where they cross. It is consistent and independent. You don't even really have to graph it. First day? Yes. Perfect. Stop. Go. What?